Chet, welcome and take it away.
So there's FOMO, fear of missing out. I guess there's FOBs, fear of being a speaker. Hi, everybody. Welcome to Modern Android Development. I have about 1 million slides, a lot of content to explain what we mean by modern Android development. So I'll dive right in. First of all, I should point out, we have been using the phrase modern Android development for a while. And we've even given some presentations on it. So the point of this presentation is to sort of collect our ideas and say, okay, here is what we mean. This is the current definition of modern Android development. And it's not just what do we mean by this phrase, but more importantly, what are the things that we believe Android developers should tune into to understand how to create better applications more easily. So historically, we have talked about this a few times. In fact, back in 2018, I gave a session with Romain in Paris at Android Makers called Modern Android Development. And then we also gave it at Devoxx France shortly after that. We also gave it at Google I/O in 2018, a few weeks after that. And then in 2019, we gave a session called Modern Android Development at the Developers Summit. And then at Google I/O, no, not another Google I/O. I think there was one in Greece that I don't have a picture for. So we've talked about it a lot, but we have sort of meant varying things by these presentations. Now we've sort of collected everything, and here is the explanation of what we mean when we're talking about it. First, a bit of history. So classic Android development was, where did we come from? And then how do we view the modern stuff? So a little history lesson. Back in late 2007, the first SDK release came out, lovingly called M3. It was Milestone 3. It came out with a lot of the things that we know and love today. It was actually a fairly full-featured platform, although obviously the team kept adding to it before they got to 1.0 and then thereafter as well. So we had the Java programming language. We had a ton of APIs in there for actually writing the applications that you needed to write. We had the ADT plugin for Eclipse, which was the IDE that we kept working on for several years. And we had the ability to zip up all this stuff into an APK, and that's how you distribute your application on the Play Store. Then 1.0 came out about a year later in 2008, and we spent years and years continuing to refine the platform and add more APIs with every release. Android Studio came out in 2013. We're still supporting Eclipse, but Android Studio was the way forward. Kotlin support came out. So Kotlin, the language was there, lots of developers using it, but we finally officially supported it in 2017. And architecture components, this is a kind of huge thing. It was us taking a step back and saying, what are the really complicated things about Android development? There are many, right? This is a very full platform to write applications for. But what are the things that we could do as platform developers or developers on the platform team to actually simplify it and make it easier to do this stuff? And then app bundles came out more recently for a better way to distribute applications. So on the language side, we're going to look at sort of 4 tiers. This is the way that we think of modern Android development. One of those is language. We obviously came out with Java programming language first. This is the way that you write Android SDK applications. One of the reasons for taking this approach to the language, we had considered several internally. And obviously the NDK came out at some point soon after this. So native development is there as well, but really the Java programming language was the main one. And one was because so many developers know it, right? So it sort of lowered the barrier of entry for developers. They didn't have to spin up on a new language as well as the new APIs and new way of writing these mobile applications. So build on that large developer base. There were free tools, including Eclipse, other Java development tools out there. There were lots of libraries, lots of patterns and practices that people use. So again, lowering the barrier of entry. We know how to do this. Now we just need to know the new APIs in order to target this platform. Memory management, you didn't need to worry about allocating and freeing, basically modern language capabilities. On the tools side, we had, as I said, Eclipse and the ADT plugin worked fine. First of all, it was free. That's always good. from the beginning, the tools and tool chain that we have offered for Android has always been free. This has driven a lot of the decisions that we had in terms of source code management, as well as development tools, that we couldn't expect people, massive amounts of developers to sort of be a part of this ecosystem if they had to buy expensive tools just to figure out how to do it, right? So being free was actually a really good selling point. A lot of developers used Eclipse already, whether it was for native development or Java development or whatever. There was a lot of stuff in Eclipse, or various versions, various things that were built on top of Eclipse. So again, lowering that barrier, right? Giving people something that they're already familiar with to develop for the new platform. Also, it was free. That's always good. There was the ability to integrate other tools. So there were lots of different tools that we were writing for memory management, for performance, for obviously the code writing, debugging, like all this stuff that an IDE does, and we could integrate those into a single tool. And then finally, it was free. So that was nice. On the API side of classic Android developments, we basically had the platform, right? So we had frequent releases. We would come out with bug fix releases, new functionality all the time. In fact, really, really frequently, especially in the beginning. This is, startling new functionality like, handling LTR, RTL, being able to localize and internationalize your application for different markets, being able to handle new capabilities like a soft keyboard in one of the follow-on releases, like really pretty fundamental stuff that was coming out as new functionality in every single release in these frequent releases. And obviously lots of bug fixes, because we have found as software developers that it's actually impossible to write code without writing bugs along the way. So then you need to fix those. At which point you probably inject more, and then you need to fix those, and on it goes. It's the virtuous triangle of job security, I think is what we call it. So if we look at historically, we came out with 1.0 in late 2008. 1.1 came out fairly quickly after that. 1.5, I think that was the Cupcake release, came out early 2009. 1.6, and you can see, look at these releases. I mean, they're coming out every few months. There were often 2 or 3 releases actually being developed in parallel on the team, just because there was so much fundamental stuff that they had to come out with. And then finally, along the way, things settled down to more of an annual cadence, which is kind of where we're at now. Right. For one thing, developers have a hard time absorbing all this new functionality. Also, manufacturers, partners have a hard time absorbing this and then pushing that into their devices, just qualifying the release to ship out with the hardware that they're shipping. So an annual cadence really makes a lot more sense. Once we've sort of gotten all the fundamentals there, then we can take a little bit more time for each of these releases. So there we go, Android 10. And on the distribution side, so this is the 4th tier. So what were we doing there? We had APKs. It's basically a zip file. Or a jar file. We call it an APK. You bundle everything up, you drop it on the Play Store, and then it drops down onto the user devices. But what happens when your users have different configurations? They're using different languages, or they have different screen form factor configurations. Well, there's a couple of ways of handling that. You could have a different APK for every single situation, and then it's on you to manage that plethora of releases that you have for these different situations. Or you could just have one monolithic APK that handles everything, but then every user downloads the monolithic APK, meaning they're getting a lot of stuff that they don't actually need. Okay, so some of the problems from these classic approaches to Android development. On the language side, it's still a good language, right? Obviously, it was a good choice then. It's a good choice now, but it is verbose. There are modern languages approaches that we could do better with than the traditional approach in Java. On the tools side, Eclipse and ADT worked, but it was difficult for us to customize it to build in particular tools, right? The subtools, like we did integrate them to the extent that we could, but they had inconsistent UIs. Everything was just a little bit clunky there. The core IDE, it was, I mean, they did a really good job early on, but then they sort of reached a certain market penetration, and then there really wasn't the drive to continue working on it. And so it wasn't actually being actively improved, the fundamentals in that tool at that time, at least not to the extent that we needed it. I would often go to the team and say, wouldn't it be nice if the tool did this instead? And they'd say, yes, it would. And we cannot do that. Right? That is not at the layer that we can affect on the Android side, and there's maybe nobody on the other side making changes like that to the fundamentals of that tool. And we didn't really control that experience, right? This was a project that was happening sort of outside of our purview, so we really could only make that tool so good. So it was time for something new. On the API side, on the platform side, the problem always has been like, yes, that's new functionality. It's really cool. These are wonderful bug fixes, but I need my users to have that release in order to take advantage of that new feature, right? It's difficult for us to approach the developer community and say, hey, you should really be using this because it makes things easier, makes things better, makes your applications faster, whatever it is. And the answer would be, yes, that's nice, but that's not the release that my user has. I will talk to you in 3 or 4 years when they adopt that release, and then we'll see about that new feature. Also, there were certain complications that were built in. Part of it is just because, well, you know, developing mobile applications with the infinite amount of things you can do on these devices is complicated, right? You're talking to networks, you're talking to local storage, you're dealing with performance situations, you have limited resources on the device, you have connectivity, maybe you don't have connectivity, depending on the bandwidth concerns. There's a lot of things going on there. It is inherently complicated, but there were also decisions that we made about early APIs and performance concerns that maybe complicated those APIs a little bit more, or maybe the information that you had to understand about Lifecycles because of, you know, the way the device handles, you know, multiple activities running at the same time in a constrained device meant that you really needed to have a really good grasp of really complicated lifecycle situations. And so there were inherent complications that maybe we could do a better job of. And then finally, on the distribution side, APKs were great, but a lot of developers would end up shipping these monolithic APKs, which meant that users would end up getting way larger applications than they needed because they weren't running in all of those locales. They didn't have all these different screen form factors, right? So they're basically downloading and installing and having present more bits than they need. All right, so the answer to this, we believe, is, again, what we call modern Android development. I'm going to go ahead and read this because it's on the screen. Development tools, APIs, language, and distribution technologies recommended by the Android team to help developers be productive and create better apps that run across billions of devices. So there's a few key elements in there. It's about being more productive because we believe the APIs and capabilities we're coming out with make it easier for you to write your code faster and to be more robust and to scale across billions of devices, because everything I'm talking about is not tied to the platform itself. These are not platform release capabilities. These are the unbundled libraries and APIs and tools and language that you can choose to adopt. They're all optional, but that is why we're talking about it, because yes, they're optional. You don't have to use these. On the other hand, we think you should, because we think it makes your development lives better and your applications better. All right, so there are the 4 tiers that I already brought up in terms of the classical ones. We have the language choice, the tools that we talk about, the APIs that you should be using, and the distribution. Underneath all of this, obviously, is the foundational stuff. It's not like we're taking away the platform. It's not like you don't need to know what an activity is. There are these fundamental things about Android development that still exist. And that's on the platform side as well as distribution. So we'll just sort of take those as read, but then we're building on these optional components on top of it that we believe you should be using. All right, so first, on the language side, we do think that you should be using Kotlin. So historically, if we look at it, the language came out a while ago, 1.0 in 2016. Language is much older than that, but 1.0 in 2016. And then finally, in mid-2017, we officially supported it. Many of our developers were using it already. They weren't terribly happy with us because every release of the tools, we would break them because we didn't officially support it. And so there was disconnect between the tools that we were offering and the language support that was needed by those tools. So we would break it, and then there would be a fix, and then the cycle would repeat. Finally, we officially supported that. In fact, the tools team actually does a lot of development now internally in Kotlin. So there's a much better support mechanism there, and basically we do not break you anymore. That was the biggest change there. And then more developers felt more inclined to actually jump into the Kotlin pool and take advantage of that. And then we went Kotlin first. Last year in 2019 at Google I/O, basically, if you're starting a new project, we think you should start it in Kotlin, and we are also doing a lot of development in Kotlin. I'll talk a little bit about that later. And also lots of training and capabilities that we're coming out with that make it a little bit easier to learn Kotlin and to spin up on becoming a good Kotlin developer. All right, so why did we choose Kotlin? Sort of 4 reasons you can think of: expressiveness, the ability to say a lot more with a lot less code, less boilerplate. It's so much more concise when you're using Kotlin. Safety, the ability to actually catch those errors at build time instead of runtime, because they build in capabilities like nullability, type information into the language itself. So it just makes it a lot more robust because you can catch really common errors before your users catch them for you. Interoperability was really key. When we approached developers for years and asked, oh, by the way, would you like a new language? The answer was always no. Like, got enough things going on, I don't need a new language. Oh, unless it's this Kotlin thing, because that actually works really well with Java, right? It's not like we're going to, push reset and go rewrite all of our APIs in another language. Like, if it's not broke, don't fix it, right? That doesn't need to happen. But if we can provide a language that gives developers the capability of actually using all those existing APIs at the same time as using a better language to take advantage of them, then that is sort of the key. And then developers said, no, that language choice is a good one, because now I've got all my old code, I can keep that, I can migrate to new stuff, and I can have them interoperate in a really powerful way. And then finally, structured concurrency. A lot of the capabilities that have been coming online in the last couple of years in the language are very powerful. You can get away from sort of the spaghetti code of callbacks all over the place, and instead write code that's is a lot more logical to write and a lot easier to read and understand what's actually going on in these complicated asynchronous operations. All right, so let's take a look at a little bit of the language capabilities in practice. So we've got nullability in the type system, the ability to actually say this can be null or this cannot be null, and then the code that calls that needs to obey that contract, or else it throws a build warning or a build error. Sorry, I'm going to correct that. It throws a build error if you're not obeying the contract, which means you're going to catch that error at build time instead of runtime. Lambdas, a really concise way to insert this function directly into the code, and then some nice syntactic stuff where you don't even need to put it inside the parentheses for the function call. Makes it a lot easier to read instead of having all these random symbols flying around in your code. Extension function, my favorite feature about the language, because it gives you the ability to sort of fix and migrate APIs without breaking the old stuff. The problem with API development is you cannot remove the old stuff because you will break applications, right? So all the old stuff has to stay. But then how do you keep, do you add, new methods to the string class? Well, if you do that, then people on the older releases don't get those new methods. Extension functions gives you a nice way of making them look like you're adding APIs to those existing classes, to those older classes, but instead they sort of exist on the side. You're basically injecting these functions in syntactically. So you could have things like, I want a capitalized function on string, and I will call that from my code, and logically it does exist on the string class. Realistically, it does not, right? It's not part of string. Instead, it's an extension function that I created along the side. And we're adding a lot of extension functions in the platform team in this thing called KTX to allow you to do just that, to take advantage of new powerful APIs without upgrading the platform and knowing that your users have to upgrade the platform to take advantage of that. And template expressions give the ability to say format strings in a much easier way than you could with the Java programming language, and have that actually checked at build time as well. Pretty powerful. And then properties as well. You don't have that problem of, well, you need to make your fields private, but then you need to have public getters and setters, and like everything was done by contract in the Java programming language. In Kotlin, it's just built into the language itself. You have these fields, they are properties, they are exposed as getters and setters. They're accessed through the dot syntax, but they actually run through the functions that get and set. Very powerful and yet concise, which kind of defines a lot of the language features. Also speed, which I mean in a couple of ways. One is the speed of development. So a couple of years ago, they were working on this experimental feature around coroutines, and then it's in the language. And then Flow was experimental, and now it's in, I think it's in the runtime library. But just really fast development of these very powerful language features. It is a relatively young language. They're running really fast. And adding in lots of powerful things, both in the language itself, as well as through this powerful extension function mechanism. They can make what look like language changes, but again, they're just sort of changes on the side that allow you to take these things on without learning these huge new language things. Like they don't need to break the language in order to add these new capabilities. Also, speed of development and speed of development. The second one was just the amount of time it takes you to write the code. There's a lot less code, but also you can just be more productive in this language, we feel. A lot of developers obviously like this already. 6% of pro Android developers use this, and 70% of the top 1,000 apps contain Kotlin code so far, and I think that number is growing. There's a lot of initiatives that we have at Google on the Android team around tooling, lint checks all the time. We have a dedicated compiler team that works with a compiler team from JetBrains. They're working on things like R8 optimizations and speeding up annotation processing. We're also adding things like annotations to platform APIs. So we have these different annotations that we add that allow you as a Kotlin developer to take advantage of language features, even though we're putting them in the Java programming language based API. So we can say at recently nullable or at recently non-null as an annotation. And that means that if your code is calling those platform APIs with code that does not obey that contract, then that will flag as a build warning and you should fix it. On the other hand, maybe it was at recently in the last release, and we've upgraded that to be just flat out at nullable or at non-null. And now if your code is calling it incorrectly, you will have to fix it. It will be a build error, but you will thank us, because wouldn't it be nice for you to fix that instead of for your users to complain about it in the real world? KTX I mentioned earlier, we are adding in capabilities, sort of API capabilities, but outside the platform, because we're basically adding extension functions to existing classes. Let me give you a quick example in the bitmap API. So let's say you want to create a drawable from a bitmap, and then you end up with app code that looks something like this. You need to save out your old bounds, and you need to set the new bounds you're going to draw to. You create the bitmap with the appropriate size and configuration. You create a canvas around that bitmap. You draw into the canvas, and then you restore your bounds. There's an extension method called toBitmap that does all of that, right? So you give it a width and a height. And one of my other favorite Kotlin language features is it has a default parameter in it. You don't have to pass in a configuration. If you don't, it will create the configuration that you probably wanted anyway, which is our ARGB 8888. So all you do is call toBitmap, and you're done. And internally, it basically does the same thing. So this is syntactic sugar, but it's really powerful because Kotlin and all of these APIs that we're creating are all about writing less code to do more stuff. We have been working a lot on Kotlin-specific APIs to make it easier for Kotlin developers to use all of these things. In Room and WorkManager, we introduced coroutines to make all of that asynchronous behavior much easier to program to. Paging 3 was completely rewritten. You should check that out. Again, coroutines and Flow for this inherently asynchronous thing of streaming in the data from the database in these pages into your recycler view. And then Jetpack Compose is being built completely in Kotlin to take advantage of all of this stuff. Lots of docs and training and samples that we're coming out with all the time. On courses, I should point out that just in the last few days, we launched a new course called the Android Basics in Kotlin course. I had a link to it up and I lost it now. So check that out. Very powerful way, especially for earlier beginning programmers to learn Kotlin as well as Android development. Lots of articles and videos on how to use all this stuff, especially some of the more involved stuff like coroutines and flow and some of the new APIs we're coming out with. Kotlin Vocabulary Series is a series of articles and videos to teach you, how the stuff actually works on the inside and how you can take advantage of it in your application. All right, on the tool side, all of that was about language. On the tool side, we have Android Studio. Historically, it announced in 2013, and then Eclipse was maintained for a few years, and then finally in 2016, we said, no, Android Studio is not just the way forward, it is the way. Eclipse needs to go away. We also introduced Constraint Layout Editor, which is a really powerful way to build much more visually interesting UIs. And then we introduced Kotlin supports and also the new set of profilers, which we keep building on. So at that point of CPU, memory, network profilers, and then we've introduced other profilers since then. We introduced D8 for better tool chain for creating the DEX codes, and then added to the profilers with energy as well as systrace, sort of whole system performance profiling, and added in navigation editor. This is really interesting because it's that neat marriage of API and tool where we gave you an easier way to define the navigation flow through your application. Then we gave you a tool to visualize it and create it as well. So now you can sort of go back and forth between code and tool to do this, what used to be really complicated behavior of fragments and activities and navigation through everything. View binding came out recently in the tool as a way to get away from all that boilerplate find view by ID that everyone knows and loves. And then more recently, 4.0 came out with Motion Editor. Motion Layout already existed, subclass of constraint layouts, but it's a little hard to write all of that very involved code to do these animations. It was always built with the tool in mind, and now the tool is available to allow you to create these really rich animations in your application. In the meantime, IntelliJ overall, the fundamentals, and then Android Studio on top of it, always has had these powerful capabilities to take advantage of. Lint checks, tight integration, and more its integration with the existing APIs. The navigation is a great example of that, but also Motion Layout Editor. But basically everything, the new database inspector, everything that we're doing right now, we work with the tools team closely to say, now, how can we expose this in a visual way in the tool to make it easier to use? On the API side, I want to talk about the unbundled libraries, which are basically a subset of Android Jetpack. It's not all of it. Jetpack is huge, right? But what we're talking about is the optional pieces that we really think you should be using on a regular basis to simplify and improve your development process. All right, so these came along. I'm gonna peg the first one as constraint layout. When that first came out, and then architecture components, I talked about this before, kind of huge for simplifying a lot of the development experience. Jetpack was announced. We also introduced paging and navigation and WorkManager for job control, material design components for, we'd already given you a way to design your application with material, but it was not obvious how to get there with the built-in components. So we came out with components to simplify that. Camera X came out recently, went beta recently for simplifying camera developments, and then Motion Layout and Motion Editor together are really sort of the next step for these modern APIs. Constraint layouts, of course, a way of creating these richer UIs. Think of it as relative layout plus or done right. The ability to lay out everything in your UI relative to each other, including guidelines, including these grid concepts, which again, we told you the design concepts behind them, but we didn't make it easy to actually define them. But now the tool plus the APIs for constraint layouts do make that easier. And then motion layout and motion editor. So take the idea as a constraint layout and now building the idea of transitions into it where you can have a before and an after state, and then define this rich animation and customize it between them. Not only that, but also allow user interaction, so you can basically scrub that animation as you scroll along in the UI or whatever. So it's really kind of transitions on steroids. Transitions was kind of a set and forget model, but motion layout and then the editor built on top of it allow you to do much richer version of that stuff. Life cycles were always really complicated. Not only did you need to understand this entire chart, actually a much more complicated chart than this, but you also needed to then override all of these methods in your activity. If you wanted to know what was going on in a life cycle and you wanted to have some effect over it, which basically you do as an Android developer, then you needed to override all of these because there was no other way to plug into the life cycle. So all of that goes away. You should still have some basic concept of life cycle, but now it's a model of observation, right? So now you can add an observer to app-compat activity or fragments. They both have the ability to observe, and then you just listen in, and you can receive any one of those lifecycle events that you would like to find out about, or you can actually query them directly. We never allowed you to say, what state am I in? Now we do. This also allows us to move to a model where we can now separate the UI and the data in your application a lot more easily. So you have all your UI components over here, all your data over there, and then you can observe. So you have this loose connection instead of sort of lumping everything into your activity code. So you say, I'd like to observe some stuff. And then when things change in the data, then your UI gets a callback and you can respond to that appropriately. The data layer builds then on top of probably a database underneath and potentially a data access object layer on top of that. So let's say you're using SQLite, you have your DAO sitting on top of it, looks something like this, right? So nice sort of type safe model using annotations that allow you to define the queries and have them checked at build time. Not only that, but the ability to then build in coroutine support. So you can do this inherently asynchronous programming in a much more obvious way. So you've got these suspend functions for doing insertion, because honestly, you shouldn't really be doing that insertion on the UI thread. So how do you easily sort of get off to a different thread and then come back? And coroutines make this a bit more obvious instead of having that sort of spaghetti callback code all over the place. Or you could take the paging approach where you've got a recycler view and you want to page the data in, and then it's a similar model, except now we return a page list object that you observe instead, LiveData, that page list. All right, they all work together here. I'm going to go pretty quickly through this thing. I should point out too that even though we're talking about LiveData and ViewModel and all these things working together, where you're doing coroutines for all that asynchronous programming, but you could also use RxJava. We're not saying you have to shut down your RxJava. If you love it, if it's sprinkled all throughout your code, you can keep using that. And we do have some APIs that are meant for RxJava developers to integrate with that. But if you are not using RxJava, but you always want to take advantage of some of those capabilities, we're sort of, with some of these things, we're giving you an easier way to do that instead of taking on the monolithic RxJava in order to get this. You could just get that capability from, let's say, LiveData instead. But we're not cutting it out of the equation. If you want to continue using, that's fine. Navigation component, we've come out with some new templates recently that make it a little bit easier to get navigation automatically in a new application. So you create it from the template there. Basic activity will then give you these two fragments. And note that with navigation, we really are recommending that people move to a single activity model for the most part. Makes the UI experience a lot better. And then we're making it a lot easier with navigation, so you don't have to figure out all the intricacies of fragments in order to make that work. So it gives you all the basics there. This, of course, is all laying over a XML code that represents the same thing. You have these different fragments, and then you have the actions that define how you navigate between them. And then to navigate, you just say, I want to take advantage of that action, and then the navigation system automatically swaps in that new component. Realized I have 4 minutes to go and quite a few slides, so I'm going to start ripping through a bunch of these. Navargs is really powerful for creating the bundle of information you want to pass between these fragments. Otherwise, it tends to be a little complicated. As I said, we are recommending single activity UIs, but we're simplifying it a lot with the navigation approach. And we're also simplifying up versus back. It turns out that there was rather inconsistent approach that developers would use for this. But if you're using navigation, then it's going to do the right thing. You can think of them as basically being the same thing, except up can never take you out of the application. It'll just take you back all the way to wherever you started. WorkManager at a glance. WorkManager simplifies running jobs, deferrable work. It's basically doing the same thing as your applications needed to do internally. Like maybe you were using Job Dispatcher, or maybe if that wasn't available on this release, you would use this this Play Services approach instead, or the Firebase Job Dispatcher. Or if none of that existed, then you would use Alarm Manager. It kind of builds in that capability internally into one single API that goes back to API level 14. You can do periodic, these jobs that happen occasionally. You can have jobs run together or in serial fashion, and you can chain them together. So easy example here, you want to do several filtering operations, which can all happen in parallel. When all of those are done, you want to compress that file, and then you want to upload these. And there's possibly different constraints around each of these. Like I want to make sure that I'm plugged in when I'm doing this expensive operation. I want to make sure that I have connectivity when I do the upload, whatever it is. So let's see. So you define your constraints. You say this. Here's a constraint that says I want to make sure that my battery is not low when I do this thing, and then I define the filter, this work that I want to do using those constraints, and then I can chain together a bunch of these to either run at the same time or in sequence, and then I enqueue the job, and Job Manager takes care of the hard part for us. Or new capability, you can also use WorkManager to set up a foreground service. Camera X, as I said, came online in a beta version recently, works all the way back to API 21, gives you consistent, it's not just across releases, but it's also across devices, because there tended to be different implementations of camera capabilities across the wide spectrum of devices available in the world. And it takes a bunch of the workarounds that you used to have to do in your code if you were using Camera or Camera 2 APIs, and sort of puts them in the library. And also just makes it easier to use for a lot of the core use cases. The 3 use cases they handle are preview, being able to actually see what the camera is seeing, analyze that image, and do some machine language processing on it, and then capture, actually snap the photo and save the file. So for capturing, here's a simple example. You set the target resolution size. I should point out here we're asking for 600 by 800. Well, what happens if the camera doesn't support that exact size? If you were not using Camera X, then you would have to handle that error and then do something else. Camera X will say, well, we'll get something close enough for you. So this is all about sort of simplifying that experience. Bind to Lifecycles, so you don't have to worry about sort of opening and closing the camera at the right times. It does that act for you. And then take the picture. So fairly straightforward approach. We release these things very, very often. Every 2 weeks, there's releases of some of the large suite of Jetpack APIs. We're continually working on new things all the time. So check those out. And then finally, really quickly, on the distribution side, Android App Bundle came online in 2018. It's about a better way of distributing applications. So a lot of the phones out there really don't have much space if you consider the wide ecosystem of Android across the world. And the problem is that the less free space someone has, the more likely they are to uninstall your application, right? So if users don't have free storage, they're twice as likely to uninstall your application as if instead they had a device with tons of storage on it. So large APKs can be a problem because it can mean that your application is going to get uninstalled. Meanwhile, also the larger the APK is, the more likely it is that it may fail in or get killed in the download and install process. Maybe the user chooses not to do it. Maybe the bandwidth was not sufficient for it, whatever the reason is. But the smaller the APK is, the more likely it is that it's actually going to get to where you want it to get. And then also, just the smaller the download, the more installations there are in general, if we just track the data. So the way it compares to legacy APKs, if you look on the left-hand side, this is a monolithic APK. This is sort of the traditional model. I'm going to put this thing up on the Play Store, and then every single user is going to get every little bit of it. If you look on the right, I'm going to put this app bundle up on the Play Store, and the app bundle is going to look at the device it wants to download and create an APK that is tuned to the configuration that the user has and download only those bits, right? So they'll tune that. It'll be a smaller download, smaller install, and smaller footprint on the device. Here's a different way of looking at it. Same thing, you have the app bundle, and that gets downloaded to these different devices on the right. And different pieces of it go down because every user does not need everything. It also integrates nicely with dynamic feature delivery. So you can have these optional features that aren't, again, going down to every single device along the way. There are over 500,000 apps using app bundles in production. 35% of those of active installs happening are using app bundles, and almost half of the top apps and games are using them so far. So pretty good uptake so far, but we do recommend that developers look seriously at this for your applications. You can get, in general, this is an average number of 20% size savings versus that monolithic APK situation. So if we put it all together, talking about these 4 tiers again, we have the language sides, basically talking about Kotlin. Check out Kotlin, it is the way to go. Android Studio for tools, obviously. And on the API side, everything from architecture components for simplifying development to constraint and motion layout for simplifying richer UI development, to Camera X for specifically for the camera situation, making that easier and more robust, and material design components for getting material design experience, but with the components that we give you to make that a lot easier. And then finally, Android app bundles on the distribution side. If you want to learn more about any of these pieces, here is a page that you can go to for more. And that is it. Thank you.
Thank you.
Awesome.
I guess the two of us will clap so that that's some applause. Yay!
Thank you. Thank you very much. Thank you.
It's hard to have an online event and have clapping.
Well, it's better than if you're crying. That would have been, that's a different indicator entirely.
All right, thank you so much for the talk. So we'll take a little bit of questions since you ran over. Let's see. So people, if you would like to ask Chet a question about the talk, please use the Slack channel. Day 0900 is military time because we want it to be sorted instead of the name of the talk. So of course, it's Colorado time since both John and I are based in Denver. All right, so let's see questions.
I see some questions. Yes.
Yeah, Ash asks.
Constraint layout motion. Do you want to read these? I can read them here.
You can read them. Okay. I'm just playing host, but you can also do it yourself.
Okay. Will constraint layout, motion layout tooling work with the Jetpack Jetpack Compose? That is the plan for them to integrate, because we know that we just got people on board for doing this powerful UI development stuff with the tool. The details of that, I don't know if they're nailed down, but that certainly is the intent for Jetpack Compose to offer some amount of that stuff. So details TBD, but yes, that is the intention. Let's see. I wish we could get save instant state bundle when observing the lifecycle owner possible. I will submit that as a feature request. I will not answer that. Is Jetpack Compose going to replace XML for UI? So replace is a funny word to use, right? We will come out with Jetpack Compose sometime in the future. And that will be the way forward for Android UI development. We believe that it's a good way to go. However, we also believe that there are many, many developers and a lot of application code out there using the existing stuff. We're not deprecating the old stuff. It's not going away. We're not expecting that just because we offer Jetpack Compose, you don't use your old stuff anymore. Instead, what we envision is that if you're writing a new application, hey, maybe Jetpack Compose is the way to do it. Maybe you want to migrate some stuff. Maybe as you add features, you could use Jetpack Compose. The team is working on making sure that you can actually have applications that have both. So you can have the view hierarchy with Jetpack Compose in that view hierarchy. But that old stuff is not going away immediately. So yeah, in the long run, we do see that people would use this instead of using the XML-based view hierarchy approach. But we're not, deleting that code, right? Let's see. Anyone catch that final URL? You know what? Can you still see? If I go back to that slide, can you catch it? Or you know what? I'll type it in the chat here.
Somebody beat you to it.
Yes. Perfect. Okay.
But we'll leave it on for a little bit so people can also see it on the screen. Yeah.
I was worried about that, but I was also worried about the fact that I was already 5 minutes over time. Are there any improvements around Android Studio's performance, especially when building an APK where it stops slowing down my Mac? That team is always working on performance. Some of the improvements more recently have been around annotation processing, incremental annotation processing, a lot of the Kotlin stuff. If you listen to the ADB podcast that we did with Mads recently, he talked about some of those performance improvements on the Kotlin compiler side. So yes, there are improvements. Yes, we know that that we're not done. There you go. Let's see. That's all that's there so far.
Yeah.
Nope. Any hints about Android Studio on Apple Silicon and on iPad Pro? This is the part where I say we don't talk about future developments. So,
about the tradition,
nice.
Right?
How does modern Android development compare to other modern platforms like Flex and FX? By modern, you mean what exactly? I believe Flex went away many years ago. No comments on JavaFX. Yeah, so we'll take that question as more of an entertainment. Should we expect bundles to be a requirement? I don't believe that's the expectation. I think we expect people to adopt it because it has benefits instead around the stuff that I talked about, as well as there's an interesting article on Medium a few weeks ago. It's linked in one of the Now in Android articles that Wojtek posted about app signing, and app bundles offer some advantages there as well. I didn't mention it in this presentation, but basically instead of putting the onus on you to take care of your keys, and then what happens if you lose it? Like, we can't get it back for you. There are these horrible situations where someone lost a key and then they basically needed to change everything about their application and have a new one because there was no way to get that old information back, because security is important. But if you have us manage your key, either you can upload that key or have us generate a key for you. And this is part of the app bundle process as well. If you want it to be, then we can take that burden from you as well. So we think that there's more and more advantages that we're building into app bundles, and it will be the way that developers want to go forward, but it's not being pushed as a requirement right now. No mention. Wait, I'm getting behind here. How does modern? Oh, I did that. No mention of Flutter. Correct, because I'm talking about Android development. I'm from the Android team, and we believe Android SDK is the best way to write a native Android application. Can Android app bundles be used outside of the Play Store? It integrates tightly with Play Store capabilities. You upload that app bundle, and the Play Store has the logic internally to turn that into the APKs that get downloaded onto those other devices. I don't believe there's an intention of doing that otherwise. There's a question for you, John.
Yeah. I've got a list that I'm keeping.
For
I was just
360
thinking about.
Flex.
I was thinking about 360 Flex like yesterday for unknown reasons. I think it was in a conference center. Oh, it was in eBay, I think, in San Jose.
Oh, nice. Yeah.
10 years ago, something like that.
Home turf.
Can we expect improved documentation on the Android plugins, Kotlin, Gradle, DSL? Finding the alternatives to some previous one-liners is often difficult or very verbose. I will also take that as a feature request. Bundle tool will render APKs from the bundle artifact for local testing purposes. Okay, thank you for that answer. Android Studio is very good at keeping my hands warm in the winter. That's great. That was the intention. I also like it for producing, for people that come from big cities, where if you're living in the country now, it's a little disturbing to not hear anything. Just that white noise that your fan produces, I think is healthy for that situation. Cooling feature for the summer. Again, I don't talk about future development. Android app bundles, is there a way to know what would be the size of my device download before uploading? Like someone mentioned testing before, like I believe there are things that you can do to test different situations, so you can get a handle on it that way, but I don't know the details on that.